Hello everyone, and welcome to Application Development with ASP.NET, episode number 8, with your host, Mr. Nelson Lakay. Hey Nelson.
Hey.
Zach Parrish is also joining us tonight.
Hey, how's it going?
It's going pretty good, thank you. And myself, Jason Busby. Now here in episode number 8, we're going to continue where we left off in the last episode, which is getting all of our tools in place, if you will, basically getting the project all set up with everything that we need to facilitate the creation of our project management system. And now we're still not done, speccing out the project management system. We've really only talked, just about one small part of it, but it's still good to just, jump in with this basic starting point, treat it as a stepping stone, if you will, just so that we can get a project up and going with everything that we need to go forward. So in the last video, we took a look at getting InHaml, .less, and Autofac, and we spent some time with some examples going over InHaml and .less, but we really didn't take a close look at Autofac, because with Autofac, we need to have at least a basic understanding of what an IoC container is, and even then, we need an understanding of what IoC means, an inversion of control, which leads us over into dependency injection, because really it's, at least in my opinion, IoC is just another way of defining dependency injection, or the dependency injection pattern. Now over in Nelson's Corner right now, we are working through taking a look at various design patterns, and IoC is one that is going to be coming up, so we will be giving a greater talk on dependency injection.
Now, is IoC actually a pattern?
No.
He's going to say no, and I agree with him. But it depends on who you talk to. It depends on what article you read. Depends on what book you pick up. Because you can easily find inversion of control pattern, but really it's a design principle. It's a methodology. It's the pattern here is the dependency injection. That is a pattern.
I didn't mean to throw you off. I was just
no, you didn't throw me off at all. Go ahead, Nelson.
Okay. Well, I mean, are we going to start with Autofac so I can?
Yeah. Well, just wrapping up the intro. So tonight, that's what we're going to be looking at. The primary thing is Autofac and getting a basic understanding of dependency injection and IoC. So with that, take it away.
Yeah. So what Jason was talking about, that IoC is a methodology. Dependency injection is a pattern that fulfills that methodology, and IoC Container is a framework for working with a framework to actually do dependency injection, which in turn fulfills IoC, the methodology. Think about it like separation of concerns. So separations of concerns is another kind of methodology, sort of, general concept that you want to do in your code. MVC is a design pattern that fulfills separation of concerns by defining how you're going to separate your concerns. And ASP.NET MVC is a framework that, forces you to use the MVC pattern, which in turn causes your code to fulfill separation of concerns. So does that make sense, Zach?
So far?
Okay, so Autofac is an IoC container, and this is the homepage, code.google.com/p/Autofac, and yeah, it's really cool.
Well, before digging deep down into Autofac, unless you disagree, Nelson, should we just start out with what does inversion of control mean?
Yeah, because you've said that it is a methodology, but you haven't really talked about what is entailed within that methodology. I mean, when you say IoC, of course it means inversion of control, but what does that in and of itself mean?
You take your control and you invert it.
Awesome. That sounds like the kind of description I'd have come up with if I didn't have any idea what was going on. And it turns out I don't, so can you come up with another way to explain it?
Inversion of control is about building abstractions and building concrete code against abstractions. It's about to give
Can I draw a picture, Nelson?
Oh yeah. If you want to.
Yeah. I mean, if you don't mind me jumping in to see if I can help Zach out, and
you want to lay that flat.
Yeah, I'm just moving this around so I can get the Cintiq over here in front of me. Let's see. No, let me.
Yeah,
use
you got to
it.
go back over to Photoshop.
Yeah, I need.
It'd be
to go
great
to
if you could just
Photoshop.
draw on a website,
And then
like John Madden.
Hang on, let me clear a
Was
few
there-
things off.
Chrome extension that does that. It's really cool. I can't remember the name.
That allows you to do what?
Just draw like right on the surface of a website.
Oh,
And then this link's going to run over here and intercept. Well, anyway, sorry.
so just and I'll point out, and also over on the Autofac site, there's a fantastic article by Martin Fowler talking about IoC containers and dependency injection. But he has some really nice examples that they're abstract, but they're not abstract. They're so simple. There's not something that you'd use in the real world, but they help kind of give you a clear picture as to what's going on.
Right.
And that's. I'll draw you a quick picture just to see if you can get a general concept of just the idea of inversion, and then as Nelson continues with his description, maybe it'll make a little bit more sense. So let's say that we have. Wow, I have not drawn on one of these in a long time. Zach always warms up first, so.
This is why I warm up, actually.
Yeah, exactly. So this is my warm-up. I wasn't planning on actually drawing, but let's say that we have, and I'm going to use some of the best names in the world, a class that's called Class A.
Okay.
And Class A utilizes another class, an instance of another class, to perform some specific functionality that Class A will then use the result of in order to do something.
Okay.
So we could just simply say that we're going to, have. We could just simply say that we're going to create one of these guys and we're going to use it, if that makes sense.
And then he'll send a return back over to Class A.
But if we do that, I didn't want to draw out too much right there
Sure.
because I don't know how you got your hotkey set up on the Cintiq, and I wanted to be able to quickly undo back. But that means that Class A, and let's pretend that other box I just drew up is Class B.
Mm-hmm.
Then Class A is tightly coupled to Class B, correct?
Right.
It's also dependent on Class B. So
to get that job done, yeah.
So the first thing, let's say that this Class B is going to perform some functionality for us, but that functionality could change in different cases with Class A. The functionality that we'll call upon is the same, but the way that functionality is implemented could be different under various scenarios with Class A.
Sure.
So to break or to decouple, so we're not getting rid of the dependency yet, but to decouple Class A and B, what we can do is we can introduce an interface. So if I was to come over here.
Yeah, as far as decoupling the implementation between Class A and Class B.
Hang on. You'll see which way I'm going.
Okay. Oh, that's awful.
What?
What, that special font face he uses when he's writing?
Yeah.
Very funny.
Wingdings, whatever they're called.
Do what now?
He just said you write like wingdings.
At least I don't code like a girl, Zach.
Well, you know.
So I'll just call this Class B again. And let's just say that its fulfilling contract and interface is X, so it's fulfilling X. Just real quick and easy things to. So now, let's say that Class A is still going to instance this guy, but what we're using is Class B. So let's say we create a Class B. It fulfills the contract, though. So we've decoupled in the sense that we can have Class C come in that also...
As long as it utilizes that interface.
As long as it utilizes the interface.
Yeah. And that would handle those scenarios where we have a different type of implementation we need for Class A.
Exactly. But what if we wanted to make Class A only dependent on the interface? And as far as the functionality that Class A is going to have performed by this other class, what if it just knows that it needs this functionality performed, but it doesn't know what class is going to do it?
That's not already the case?
So, well, right now, when Class A is instantiated, we could simply say that Class A is instantiated, and we're going to, because you can't just instantiate the interface itself, because this isn't an implementation. This is just going to force a contract. So we're still having to
Instantiate either B or
this
C
guy. Now we can
to get the
keep
job done.
him in a member that is of type of that interface. But do you see how we're decoupled in the sense that we don't need to change our code
Right.
at all to utilize a different class as long as it conforms to the interface.
Right, as long as that class meets the criteria of the interface, we're good to go.
But we are still dependent on it.
Right.
So
Either B or C would have to be instantiated with Class A in order to get the job done.
So what happens if we are in one case, we may need Class B, but then in some other case, we need Class C, in whichever way Class A is currently being used. So, so basically, since we're dependent on both, we want to get rid of the dependency to Class B. We'll keep the dependency to the interface.
Okay.
So how do we do that? And this is where we go ahead, Nelson.
Yeah, this introduces what an IoC container
Yep,
does.
that's exactly. But I'm by doing this, and then I was hoping this would be a great lead up for you. Zach will at least have the concept of just inversion of control. So let's actually let me do this. I'm just gonna keep this down here. So what if we had a different scenario? So we've got Class A. Go ahead.
I actually just want to throw out an example right now.
Yeah, go ahead while I'm writing.
An example of when you would want to do this is, actually this is an example that I came across the other day when I was working with some of my code in a console application instead of a web application. I wanted to reuse some of my services. The problem would normally be is those services depended on stuff like configuration and session and stuff that don't exist in a console. But because I had used IOC, all I had was an interface called iConfig service and another interface called iSession service. And they both had methods about configuration and session. In my web app, those are implemented as ASP.NET configuration and ASP.NET session. In my console app, all I did was I wrote two different another implementation for both of those interfaces, and then I passed them into my classes that I was using. So that's, I mean, it's really important whenever you touch anything that's platform specific, like anything at all that's platform specific, you want to abstract that in an interface and use dependency injection.
Wow, I just looked up at the screen from looking down here, and it looks like it's even worse up there because it's amplified on this giant 30-inch screen with this low resolution. It's like, yeah,
that's
so,
okay.
So now we want Class A only dependent on our interface. We've got to have that. We don't want it dependent on Class B or Class C. We don't even want it to care or even be aware of those, of which one it's going to be utilizing. So we have another class over here, and this is our assembler. And it's going to be his job, and then I'm sure we'll get into discussing configuration and things like that here shortly, but it's going to be his job to determine with Class A the state in which the class implementation in which Class A will need to function properly.
Okay.
So we end up with this. So our assembler is going to be the guy who's going to work directly with these concrete classes. But watch this. Look which way I'm drawing my arrow here. The assembler is going to hand the implementation, the dependent, to Class A. So the assembler is going to say, okay, Class A is being used in this particular way, which means we need Class C's implementation of this interface. So let's go ahead and instantiate Class C and hand that over to Class A. And then there's several different methods in which we can do that, and Nelson may wish to talk about those in just a minute. But this way, Class A is not dependent on Class B or Class C. it doesn't even have to be aware of all of that. It just knows that it's holding a reference to the type that we're defining with that interface. Does that make sense?
So far.
So the assembler can make the determination under whatever conditions we define as to which implementation of the interface Class A needs in order to do its job. Okay? Because we know, obviously, Class B, Class C, Class D, all of these guys are going to fulfill the contract because they are inheriting from this interface. So Class A is holding a reference to the interface that has been supplied from the assembler. So then Class A just goes on business like usual, and it just calls the methods that are in that interface that are required to be defined. And so Class A just goes on like normal. So we've decoupled, and now we have taken the control and we've inverted it. Because originally, if we look at the top picture, so this area up here, Class A was going in and creating an instance of Class B and storing it in a type of the interface. But it was it was dependent on Class B. But now, with this being the case, now Class A doesn't have to know about Class B or Class C or any that we add at a later date and time. So if we come in and we add a Class D, we don't ever have to modify Class A, which is what we want to do. We're separating everything out and keeping everything decoupled and in such a way that we don't have to go back and recode this if we then added in a new means of providing this functionality.
Is Class A now dependent on the assembler?
Well,
maybe indirectly.
No, it doesn't have to be.
Okay.
All right, well, that gets into, how does Class A receive Class B or Class C?
And it's got to be handed to by the assembler.
Go ahead, Nelson. You were going to say something?
Yeah, there's actually two ways to do it. You can use the
Three ways. Go ahead. Sorry.
You can use the IoC container, in which case the IoC container is going to be the assembler.
Right.
And Class A isn't going to know anything about the IoC container. The IoC container is actually going to call new on Class A. It's actually going to instantiate it and then pass in all of his dependencies properly. Does that make sense?
Yeah, I think so.
The second scenario that I know about is called the service locator, which is actually something that you'll see in ASP.NET MVC used a little bit, because you have to in certain circumstances, where the assembler is no longer called an assembler. He's called the service locator. And he's just chilling out there. He's probably a singleton, statically accessible through a static method. And then Class A then asks the assembler for things. The Class A says, okay, assembler, give me this, then give me that. So he says, give me interface A or interface X. And then assembler says...
Let me give you an arrow to point with.
And that description sounds a little bit closer to what I'm seeing here in the diagram.
Well, you have to look at, in this particular diagram, the way the arrow is drawn, because it's pointing at Class A. That means the assembler has an association to Class A, but Class A does not have an association to assembler.
Right, Class A is not dependent on the assembler. But now, the assembler... Well, this gets into, and Nelson, you were right with what you said, the two types. I was still talking about how Class A received its dependence.
Oh, yeah.
And that breaks down into, there's three different ways, three different methods that you can apply for that. Type 1, as it's called, Type 1 IOC is with interface injection. Type 2 IOC is with setter injection, and Type 3 IOC, which I think, just from my reading on the net, is a more popular method, is the constructor injection. And that actually ties neatly to what Nelson was just saying, where the assembler, so this guy over here, is going to actually be instantiating this guy. But if we use Type 3 IOC, so again, constructor injection, that means that Class A's constructor will be taking in a reference of this type to this interface. So the assembler can determine under, again, certain configuration conditions, etc., which implementation of this interface it needs. Then it can create a new Class A and pass it an instance to a new one of these. So now Class A is in existence and has the proper dependent with the correct implementation of the interface to do its job.
And that seems to correlate more with the idea of the word of inversion, where it seems like from the start we had Class A to begin with, and then either Class B or C in our first start upper diagram would have had to have been instantiated based on our current needs at the time. With this new method, the assembler was actually what's there first, and then based on what we need, we instantiate a new Class A along with whichever one it happens to need.
Mm-hmm.
Right. And I'm just going to throw it out there, though, that the service locator and method or property injection, I particularly don't like. And the reason is constructor injection requires that in order to instantiate a Class A,
it has it fulfilled.
Right. Because in order to instantiate a Class A, you have to pass in all the constructor arguments. So if Class A uses the constructor arguments as a form of telling the world what it needs to do its job, and that's way more explicit, way more readable, and way more usable. And
I completely agree. And like I said, on the internet, you start reading around it, again from the articles I've read, constructor injection seems to be the preferred method. Now I'm right there with Nelson was saying that if I was going to be utilizing this, I would definitely go with constructor injection, because if Class A is getting instantiated, it has to have the constructor requirements fulfilled. And if it's looking for an implementation of this interface, then the assembler has to give it to us. So we know if Class A is in existence, then everything's fulfilled and it'll function properly. But if we're using the interface injection or the setter injection, we don't necessarily know. And now we're going to have to set up to throw an exception or go about handling it in some other way if that functionality is called upon, but the assembler or nobody basically set who our dependent needs to be.
Gotcha.
So the picture work all right for you, Nelson, other than it looking absolutely horrible?
Yeah. I mean, I'm trying to think.
I'm just trying to keep it super simple just to help Zach kind of see where the idea of the word inversion comes from.
Okay. Do you mind if I point out two things, though, that
Go ahead.
that are related to this but aren't directly what we're talking about? First, like I said before, the ASP.NET MVC, in certain circumstances, you must use a service locator, and ASP.NET MVC actually exposes an implementation of a service locator that you can override with your own IoC container, which we'll be doing. The next thing is that IoC is great as far for this specific purpose right here, abstracting away all of your dependencies. But you get to a point in code where you're writing abstractions on abstractions on abstractions, and generally speaking, when you get to a certain point, I stop abstracting dependencies away into interfaces and simply use the IoC container as a means of keeping all my objects around. And I'll that's probably controversial to say to most astronaut architects out there, but you read the article, right, Jason? It's a really good article.
Yeah, it is. Fantastic.
But the reason I do it is mainly just for convenience and I guess logic. If you have an entity persistence service, an abstract entity persistence service, an interface, and he has like a store entity, load entity, query entity, that's a good abstraction, because now you can use whichever ORM you want and just implement your own entity persistence service with your own ORM code. And then your other dependent code will just ask for an entity persistence service and it'll get the right one. But then once you start, then you build that layer that is being tied to these interfaces that are dependent some on your platform and implementation. But then when you get a layer above that, at that point, you're writing code to talk to a layer that has been abstracted away from everything. So it becomes less of an, in my mind, I see no reason. And when I started using this a few years ago, that was my first thought. Like, it's once you get to a certain point, abstracting everything into an interface is meaningless. It was only until recently that I actually started doing it because I felt confident enough that I had enough experience working with it. And I'll show everyone what I mean by this so it'll make sense. But I just want to point out right now that if this looks inconvenient to some people, I believe there are ways to make it still convenient while still doing everything it needs to do and providing all the benefits that Jason's already outlined.
Cool. Does this help give you at least an idea that if we move forward?
Yeah.
All right, fantastic. Well, I'll give you the whiteboard back, sir.
All right.
Because obviously by my drawing skills, I've demonstrated I have no need
Oh, it was incredible.
having this. And Nelson, mouse is yours if you want to jump back over to the website.
Yep.
And now Autofac.
Okay, so Autofac is an IoC container, so it represents the assembler class that Jason had outlined. And that's what it does. Just like most IoC containers, there's Autofac, Inject, Structure Map, Unity. You can use MEF or Microsoft Extensibility Framework as IoC, but this is the one that I have a lot of experience with. It's fast, it's easy to use, and I like it a lot. Generally, the way that you do it is you instantiate a container builder. You register all of your dependencies, explain to the container builder what to do when it finds someone needs an I something. And then you build that container builder out, and you use that container builder to create your objects. So to get started, go to the downloads page, and we picked the 2.3.2 for .NET 4, the non-beta.
And I think we've already
Yeah, we've already
got it, extracted it, and I could be wrong. Maybe we didn't bring the references in yet.
I thought we did. But maybe
Well, maybe
didn't.
not because I don't see it.
Yeah.
Well, you can check references right there.
Oh, we did.
Autofac. Yeah, I thought we had yesterday.
Okay, so Autofac configuration, Autofac integration web, and Autofac integration web MVC.
Yep.
So generally where you dump your Autofac code in is into the Global.asax. And Global.asax is an interesting class. Did I talk about it at all?
You have in the past. We've talked about registering routes, and we've set up some different routes to demonstrate. We've talked about application start a little bit.
I just wanted to point out, like, it's hard to kind of. The reason is this class has show me the markup. This class is really weird class that didn't really make much sense to me for a while, and at some point we need to sit down and talk about it. But I'm not. Just know that the Global.asax is where your application starts, essentially. You know, like the application start method, which is a magical method that's not it's not being overridden. It's not anywhere. It's just a magical method that's going to be invoked.
Right.
By IIS. So we're going to register IOC as the first thing, our Autofac container as the first thing. I'm going to create a method called initIOC just to keep things cleaner, and then I'm going to grab all this stuff and extract it into init MVC. That was a select code alt-inner extract method.
Thank you.
Create method alt-inner. And okay, so the first thing we got to do is we got to build our container builder. Alt-inner, that should have brought in Autofac dot something or other, just Autofac. So using Autofac to grab it. So at this point we can register all of our stuff. I'm going to create a class somewhere, and I'm just going to call it service. These aren't going to exist for very long. I just want to use them as to demonstrate. Collapse all these guys. We're going to create an I entity storage. It's going to have a store method, and it's going to have a get. After I define this, I'll show how we're going to use this, and it's also going to have a query. and all of these are generic methods. So to use this in our home controller, let's go ahead and inject this guy into our constructor. And we're going to initialize field from parameter, so now we have an entities field that we can use. And so we could just do entities.query, then some entity type to use it. Now note that this will not currently work. ASP.NET MVC assumes that you have a default or a parameterless constructor. It will not allow you to instantiate a non-parameterless constructor. But what we're going to do is once we get Autofac configured, we're going to create a Autofac controller factory so that Autofac will be responsible for instantiating our controllers so that it can satisfy all these dependencies.
Okay.
And then services, I'm going to create a in-memory entity storage, implementation of entity storage. And just like his name suggests, he's just going to store things in memory. Alt inner. So he just needs a dictionary. Of type, comma, enumerable, or list, linked list of object. Yeah.
You can do it, Nelson. All right.
No, he really can't yet.
Alt insert enter. Team viewer dialog. See.
Red. Look for red.
I'm having an issue because on the MacBook, the command key is in a different location than the control key on a Windows PC.
Yep.
Or
Yes, it is.
Windows keyboard, and I'm having issues with that right now. List equals entities. Hold on. Entities contains key. So this will just store all of our entities in a list, and that list is going to be dependent on the type. So then if that, then just do... Actually, what am I doing? If not that, then do linked list object, entities type, add last entity. Currently get when we actually write this this implementation within Hibernate, there is a differentiation between get and query, but in this case, I'm just going to do query t entity first or default. Actually, I don't even know why I wrote that method because I don't have any PKs. Just ignore me. We're not using get. We will once we have an Hibernate implementation. And so this is just going to return entities type of t entity as queryable. We're going to have to, what is it like? Oh, right. Cast t entity. And then we're going to have to make sure that this key actually exists before we use it. Control Shift RP. Oh, wrong one. V. Let's use the mouse. There we go. There we go. So there's our ternary. I don't know why I didn't catch that. So there's our implementation of our in-memory data store, and it's pretty straightforward. This can be made read-only.
Go ahead and walk through it and explain it now. just so that those that are following along that aren't necessarily comfortable with this will understand what it's doing?
All right. Well, this. Well, I guess you have to start with the interface. The interface allows you to store entities and then query entities by type. So we'll use it like something like we can do this. We can do entities dot store. You can store a bunch of strings, although those aren't entities. Let me create an entity class. Things should make more sense once I show an implementation or something using this. And to be an entity, what does it have to have on it? Zach?
ID.
Oh, has to have an ID. Okay.
Okay, so let's store a few people. I'm not going to bother to initialize them. And then to query, we could do... I'll initialize one of them. Or not. Oh. Just wondered if this shortcut worked in this particular instance, but it doesn't look like it does. Nah. There's a awesome Resharper shortcut that'll move members around. And for some reason it didn't work in that case. Actually, I think I have to hover over it. Yep, there we go. And that is, I put my cursor over the identifier and I am holding down Alt, Control, and Shift and using left and right.
Very nice.
Oh, I can even do that. That's pretty cool.
That is cool.
You can do that with, I use it for like methods. But anyway, now we can query on it by doing query of type person where we don't have link. Alt enter is going to bring in link up at the top. When do I get to stop doing that? There we go. So that's how we use this interface. And the cool thing is we just asked for an interface and we're using it. And we don't have Autofac set up yet. I realized I just wanted to show you how we would be using it. So this class, it lets you store things and it lets you query over things. And the implementation of this class is straightforward. We have a dictionary that is, the key is a type, which is a reflection. It's a type is a, well, type. Every variable has a type, and you can get the type of any variable by doing the getType method, which will return this type object, and this type will be unique depending on what actual type we're working with. So I use that to store all my objects into a dictionary that has the key of the type that that object is and a value of the actual object. And then when I query, I return if we have one of those types already in existence in this dictionary, I return it. Otherwise, I return an enumerable empty, and that's backwards. Well, it's not backwards. It's just I generally prefer to not use the not operator if I don't have to. So if we have a type of whatever type we're passing in as the generic argument, so the generic argument in this case is person. So it literally comes in here as tentity becomes the word person. So then we get the type of person, and then we get all objects in our dictionary that have that type person.
Good.
Is that what you were looking for, Zach?
That's what I was looking for, yes.
Okay. So now we can build stuff with this. We can configure it. The nicest there's a few different ways to do it. There's actually more than a few. Eventually we're going to be doing it where the Autofac is going to be looking at all the types in our assembly and using attributes to find it out, but we're going to register this one manually.
Okay.
So it's just going to be register type, then pass in the type that we're registering. This is the concrete type that we're registering, which is important, which is going to be in memory entity storage. And then Altin brought in using services.abstract at the top.
Mm-hmm.
And then you don't have to supply any parameters. But at this point, nothing has happened. Autofac actually uses a new fad, I guess, in the .NET framework called Fluent configuration syntax, where you build a configuration of something based off a bunch of methods that you call in sequence. So when we register type, we have to call another method on whatever register type returned and tell it to either do this, as implemented interfaces, or as self. We're going to do it as implemented interfaces. And then we're going to stick it in the single instance, which sticks it in the singleton scope.
Gotcha.
So what's going on here is we're building our builder, which is what configures Autofac for us, and then we're telling it about our in-memory entity storage, which is the concrete class. This is the concrete implementation of this. Then we're saying register this concrete class to fulfill any class that asks for any of the interfaces that this concrete class implements. So, for example, this concrete class implements iEntity storage. So this method right here will say in-memory storage, or not in-memory storage, it implements iEntity storage. So it says, this reads as, we're registering in-memory entity storage, and we're going to be using an instance of in-memory entity storage whenever anybody asks for any of the interfaces he implements, which is right now iEntity storage. And then we're saying that we only want to create one instance of this class and reuse it every single time someone asks for it. We also have a request. Let's see if I can remember. Instance per lifetime scope. I believe that is the request scope. So it's basically every request that hits your site for this object, a different implementation or a different class will be or object will be instantiated and reused for that entire request. And then there's also instance per dependency, which means that every individual dependency gets its own unique implementation. So if home controller depended on iEntity storage, Autofac would give in-memory entity storage to home controller every single time a home controller is created. If resources controller also depended on iEntity storage, Autofac will give it a different instantiation of in-memory storage every single time it asks for it. But we're going to use as what was that? Singleton something? Single instance. In an Inject, it's as a singleton, I believe. But anyway, so then we built our container, and now we built our builder, so now we have to build our container. So now we have our container object. And our container object has a lot of cool stuff we can do on it, like resolve. And resolve is the most important method on the container. So at this point, Autofac is created. We've instantiated Autofac, and it knows all about the stuff we want it to work with. If we wanted to get something out of Autofac, we could do this. We could say and that was Altin to bring in services abstract. So now this instructs Autofac to get us an implementation of iEntity storage. And the reason it knows about an implementation is because in-memory entity storage implements it, and we told it to implement all interfaces. We can also do something like this. What this will do is, you notice home controller is actually a concrete class, but what it'll do is it'll instantiate home controller with all of its method or all of its constructor arguments as resolved. So does that make sense?
Mm-hmm.
This actually won't work right now. It'll throw an error, and the reason is home controller isn't registered with Autofac, so it doesn't know anything about it. To register home controller with Autofac, and you have to do this for every controller in your project, obviously, you do builder, register type, home controller, which is our type that we want to register, as self, and then let's say instance per lifetime scope, probably. That probably, or instance per lifetime scope. Okay, so now we've registered a home controller with Autofac. It now knows about it, it can instantiate it, and we can resolve it with that.
Okay.
Which will in turn resolve identity storage as the constructor argument to it. Does that make sense?
Yeah, it's very cool.
Zach?
So far.
Okay. So to get it to integrate with ASP.NET, there's a few things we have to do. One of the things that we have to do is Autofac actually uses an HTTP module in order to determine what constitutes a request. So it uses this HTTP module to figure out when it needs to create everything that's a request and when it needs to dump everything that's in the request scope. And I'm going to be using I guess I should define it. At work, if anybody knows, our company used to do all Cold Fusion. And in Cold Fusion, you had the application scope and the request scope. And as a result, that's kind of how I talk now. Whenever I say request scope, it means those objects that are instantiated per request and reused throughout the request. When I say application scope, I mean objects that are instantiated for the entire life of the application, so essentially a singleton.
Okay.
Unless Jason has a problem with it.
Not at all.
Okay. So the first thing we have to do, I'm going to leave that. And then I'm going to, actually, hold on. The first thing we have to do is we don't want to do that for every controller we have. Autofac actually built us this nice little extension method that does it for us that's provided by the Integration Web MVC project. And if I could just remember what it's called, because I've only ever typed it out once. Register controllers, that's what it's called. So that was Altinder. It probably brought in autofac.integration.mvc or something. Oh, did it bring in anything?
Yeah, it did.
I did?
Integration.web.mvc.
Okay. And then we also have to pass in syntax error. We have to pass in the assemblies that it's going to search for controllers for us as a params. So we can either pass in an array of assemblies or we can pass in a list of assemblies separated by commas. You remember params, right, Zach? So we need to get the current assembly that we're working in. So just do assembly. Actually, I generally do this. I do type of the class that I'm working with, MVC application, and then .assembly. So this assembly is going to be the current assembly that we're working with, so this will register all the controllers in this entire application. Now, like I said before, the next step is to, well, really all we have to do is create a controller factory, create our own little controller factory. I'm going to create a little folder called Dependencies. And this is going to contain all of our Autofac specific stuff. Eventually this is going to go away into another project, another class library, but for now I'll just keep it more simple. So we have an Autofac controller factory, and Autofac controller factory is going to implement, it's going to inherit the default controller factory because there's a lot of stuff that we don't want to deal with. But default controller factory ultimately implements the iController factory, which is the interface that is the only thing that ASP.NET MVC needs in order to turn a request into a controller. So basically the responsibilities of this class is it takes in a request and it spits back out a controller. So for example, this spits out a new controller, and then this releases a controller. But fortunately, unfortunately, default controller factory does a bunch of stuff that we don't want to deal with. So that's why we inherited default controller factory, and we're going to override the get controller instance, which is you can see it's a protected virtual, meaning we can override it, and that's just going to be the one little piece of code that's responsible for actually instantiating our controllers. And so we're going to override it to provide our own behavior when we want to instantiate controllers. So if I could find where that file went. We want to alt insert O. We want to create a controller. And the issue with this right now is that how do we get to Autofac? There's actually a few different things that we could do. I'm actually going to do this. I'm going to... Remember how I said that ASP.NET MVC had a service locator?
Mm-hmm.
It's called a dependency resolver. And it's a static class that we can create a local variable of. And then delete the line. I don't know how that happened. Dependency resolver. It's right there. .current. It's a singleton, and it provides us a get service and a get service generic method, and we can use this to get any sort of service. It's just an implementation. It's just a singleton that wraps it. I don't exactly know what the default dependency resolver actually does. It probably just tries to instantiate it if it has zero arguments in its constructor. Otherwise, there's an exception. I've never played with the default dependency resolver because I've always implemented my own. So we're going to implement our own dependency resolver, override the dependency resolver that ASP.NET MVC uses, and then use that dependency resolver to implement this method, which I'm actually going to do right now. I'm going to implement this method using the dependency resolver. And we can do different things here. We can throw 404s, do a bunch of stuff, or we can just go ahead and do stuff. Actually, I think this is the wrong method, now that I'm thinking about it. Because we need one that gives us a type. Get controller instance, get controller type. Yeah, it's controller instance. Did I do type a second ago? I was confused because there was the second argument was a string, and it's supposed to be a controller type. So now we're just going to return a new return dependency resolver.current get service, pass in the type, which is the controller type. And actually, controller type might be null if the request couldn't find a controller. So I'm going to go ahead and I'm going to go ahead and say if controller type is null, then throw a new argument exception, or argument null exception. And then, or if it's the first one. Controller type. Okay, so this actually doesn't do anything right now because we haven't yet overridden the dependency resolver. I just particularly like using the dependency resolver whenever I have to do nasty things like using a service locator, because dependency resolver is a service locator. It's just nice because it's kind of a standard thing that's available across the entirety of ASP.NET MVC. So now we have to create our own dependency resolver, not a web control. I'm going to call him an Autofac. Let's just call it dependency resolver if I can type it again. And he has one requirement, which is to implement the iDependency resolver. Dependency resolver.
You misspelled dependency on Autofac dependency resolver.
Oh, good thing we have. Yeah, I'm bad at this game.
It's okay.
Is that it? No. You know what?
It's closer.
The lag. I type these words so fast on a daily basis that.
Yeah, I totally understand.
Okay. So get service and get services, and basically all he's going to do is he's going to accept a something, and I can't remember what that type is. What is that type? The type is a iContainer. So he's going to accept a iContainer, an Autofac iContainer. And he's also going to accept a default or a parent dependency resolver, so that if he doesn't know what to do with it, he'll just defer back to the parent. And both of these are going to be fields. Get service is just going to call resolve on our dependency or on a container. Actually, it's going to do this. It's going to resolve. Try resolve. That's what we want. It's going to try resolve object instance service type. If that works, then return true. Otherwise, return parent get service type. Then get services, basically get services is going to be used for anything that's an IEnumerable, more or less. But the issue is that the type passed in, this is kind of the frustrating thing, the type passed in is the non-IEnumerableified type. So if we ask for a get services of type IEnumerable of type int, service type is going to be int. The problem with that is we could do this code verbatim. It's just that when Autofac wants to register or wants to spit back or resolve a collection, it actually expects you to pass in the IEnumerable. The IEnumerable of type int will resolve to the collection returned by Autofac. So we actually have to do some crazy stuff that is going to. I'll just do it.
Yeah, sometimes you just have to do it.
This is the one instance where little generic thingies aren't required, or that you don't have to specify them, is when you wrap it with the type of. And what this is specifying is get the non-generic version of IEnumerable. Return that type without any type that IEnumerable has. And then we're going to make generic type, which returns the generic type of type, whatever type we passed in to the type arguments parameter.
Wow.
I just want to get type as many times.
I was going to say that to yourself like 10 times fast.
So, yeah, just this doesn't freak you out too much, does it, Zach?
Not quite. No, I think I'm with you so far.
Okay. Well, at this point, we can really just do this. Which means we could just do that. I'm just leaving out 2 lines just because it's weird. So cool. So here's our dependency resolver. And we're going to go ahead and, after we build our container, we're going to build our custom dependency resolver. Actually, I'm just going to do it one line. It's just I'm having a real hard time with that word today. Dependency resolver dot set resolver, and then pass in our own dependency resolver, which will be Autofac dependency resolver. And then as a constructor arguments, we're going to pass in the parent dependency resolver, which is currently going to be the value of dependency resolver.current, and then our iContainer, which is our builder. And it doesn't like that because I have a paren where I shouldn't have a paren. Then I have too few parens over there. And probably got the type wrong. There's so many... Oh, I don't pass in the builder. What am I doing? I pass in the container. There we go. So now we've overridden the default ASP.NET MVC service locator.
Okay.
Is everyone okay with that?
Mm-hmm.
And the next thing we have to do is set our controller factory. And I don't know what is wrong with me, because we don't need a dependency resolver reference here. We can just accept the this is another thing. It's considered the service locator is actually considered an anti-pattern, kind of, sort of. Like not like a huge anti-pattern, like, oh, never do this. It's just generally not preferred. And like Jason was saying before, constructor injection is always better. Alternatively, there's another anti-pattern that's just as bad, is when we actually inject the container. So we actually register the iContainer as injectable. So we could accept an iContainer, but we're not going to, because it's really just as bad as using a service locator. There's no real difference. Now that we're using that service locator, the cool thing is that ASP.NET MVC actually uses the dependency resolver to pick up on the iController factory. So in order to use our own iController factory, all we really have to do is register, because we overrode the dependency resolver, or the dependency thingy resolver, with our own dependency resolver that uses Autofac. MVC is now going to ask our dependency resolver to find the controller factory to use. So at this point, all we have to do is register our Autofac controller factory as implemented interfaces, which at the end of that chain will be iController factory, and then we'll just specify single instance. So now our controller factory is registered, which is cool. Good with that?
Mm-hmm.
Okay, I want to say this is the last step, but I do want to make a disclaimer right here. I'm going to do this, and then it's going to, the next time I load the application, it's going to throw an error. It's going to tell me to name a property something, and I just can't remember what that property is called. So I'm just going to put in the configuration, and then have it throw the error, and then fix it, and then it'll work. So basically, we have to add in our own little HTTP module that will, or we're going to be specifying that Autofac is going to have an HTTP module. An HTTP module is essentially like the highest level thing that receives requests and responses, and returns responses. And Autofac implements its own little HTTP module to handle the disposal of containers and stuff like that. So to register that, we need to go into our modules parameter. And I know I promised that I would talk more about the web.config. I just want to throw out there that run all manage modules for all requests equals true. If you ever deploy an ASP.NET MVC application and it looks like your routing engine is not working, make sure this is set. It's actually a really cool little property, but I'll talk about that later. We just have to add name of container disposal, type Autofac integration .web .container disposal module Autofac .integration .web precondition managed handler. And I'm pretty sure they have this actually on their website that you can copy and paste from. Just make sure I spell that right, because Resharper's throwing a fit. Let me just quickly build to make sure that work. Whatever. Let's just ignore it for now and see if it throws. Yeah, so at this point we can go ahead and run. We have, for all intents and purposes, Autofac configured. It's just that last little property I forgot the name of that Autofac is going to helpfully remind us of in a second.
Hang on 1 second. I got the mouse.
Oh, okay.
We're just going to go ahead and come on over here. And I've got it copied. Go ahead and there you go.
Doesn't like none of the constructors found on type Autofactor integration Autofac controller factor. None of the constructors. There are no constructors. What are you talking about? See any? There's no constructors. Found the public binding flags on type. This is weird. It's trying to use its own Autofac controller Oh. Yeah, that was my bad. This is the wrong Autofac controller factory. This is their Autofac controller factory. We're going to just specify our own little namespace there. And this is ours, right? Yeah, that's ours.
Yeah, because the capitalization's different.
Oh, what's up with that capital F?
You put it there.
You guys didn't tell me?
I thought you had a reason for it. And actually, it was kind of nice for a second because it helped me see that there was a difference between the original and the one you made. So I was like, hey, he really knows what he's doing, adding that capital F.
But that's not what it should be.
So I was wrong.
That's what it should be. Okay, so at this point, now we should get finally that error that says our thingy doesn't have a property or something like that. Yeah.
Unless we don't.
You might get weird stuff like this sometimes. Cannot convert a Boolean to an iController factory. That's funny. This is probably wrong. Return true. God, you guys really need to start paying attention here.
It looks like you do too.
Let's all pay more attention.
Oh, that's weird. It worked.
Do-do-do-do.
It shouldn't have worked. Maybe it's a different version. I'll have to research that some after the video because it really shouldn't have worked. I'm going to go ahead and prove that it hopefully didn't work by setting 2 people with that name. Then I'm going to pass them to my view, and then I'm going to use them. So then I just have to go to my view models and add a... Oh, this isn't going to work. Hold on, Resharper should fix it. Oh, never mind. Shouldn't it? Because that's an internal class. I don't know. Yeah, that's what I mean. It's because it's an internal class, not a public class, so I'm just going to make it public with Resharper. There we go. So that just made the class public. By default, things are internal. The view model itself was a public class. You can't publicly expose an internal class with a public class.
Right.
Mm-hmm.
So now we can loop over people. Unfortunately, we don't have Resharper and Haml files. Actually, hold on, that doesn't... Nah. I want to do something that might break. There we go. Go ahead and build, and at this point we should now...
See the names listed beneath.
should see 2 people.
Yeah.
Oh.
Where did this happen? This happened, template render. You're not gonna give me... Oh, I didn't set it. There, now we get our stupid people.
In italics.
Yeah, emphasis,
yeah,
but generally I override that. So that's dependency injection right there. Or, well, dependency injection, IoC, and IoC Container implementation. So do you guys have any questions about what's going on?
I would say for our viewers, go ahead and walk through the big picture of it being assembled now. Go ahead.
From the perspective of how we consume it, or from the perspective of how we built it?
I would go to consuming.
Okay, so essentially in our service layer right here, we have an abstract entity storage interface.
Mm-hmm.
And he does two things. He stores entities and he queries on entities. And that's to the extent that's the interface that we've defined. That's the contract of this object. And throughout our application, we're going to be storing and saving entities all the time. So we're going to need this guy in our classes. For example, in the controller right here, we specify that we need some sort of iEntity storage class.
Mm-hmm.
Or some class that implements iEntity storage. Mm-hmm. It could be in Hibernate, it could be in memory, it could be file system, it could be XML. It doesn't matter, because all home controllers cares about right now is that it can call the .store and the .query.
Mm-hmm.
Because those are the methods that are defined by the contract. And if you open up IntelliSense, you'll see that there's query and store right there.
Mm-hmm.
To actually implement this, to actually wire up an implementation of iEntity storage to the system so that when home controller is created, he gets the proper instance, we define that implementation down here. And here's another cool thing. You can have dependencies of dependencies of dependencies, meaning I could say like iConfiguration service if we had one. If for some reason my implementation depended on an iConfiguration service, we could put it right there, then Autofac will pick that up on it for us. And so we have our implementation of iEntity storage right here, and he does stuff. This is implementation details.
Mm-hmm.
He could be talking to an Hibernate or whatever. Then we have to register. We have to tell Autofac that our in-memory entity storage is the proper implementation to hand out whenever someone wants an iEntity service.
Mm-hmm.
And we do that by telling the builder to register a concrete type as the interfaces he implements, and then in some sort of scope. So this could be single instance or per lifetime scope.
Okay.
So all that basically allows us to do is be able to write our code in a really clean and decoupled way. And another really cool thing is remember our whole arguments about singletons, Jason?
Mm-hmm.
This is why I don't ever use the implementation of singletons that we went over. I'm not saying that it wasn't good to go over that, but I'm saying that's why I said that previously in the other video, that I don't find myself having to use the public static instance property, because all I can do is specify, even if this is a concrete class, it doesn't matter. I can just use my IoC container to handle the implementation of him being a single instance.
Yeah, that's the bottom line. It's the pattern still exists. It's just being handled by somebody else,
right.
Getting it away from you.
If you don't have an IoC container, you're not utilizing one for whatever your reason, then you go the other route.
Right. So, was that good enough, Jason? Or
yeah, let me think. Yeah. Actually, not bad.
Do we want to talk about something that's a little bit more advanced, but will allow an easier way for us to register things?
Sure. Unless,
Unless
judging by that sign, you don't want
unless
to.
you want to save it for the next video.
No, I want to go ahead and do it. The issue is it's going to be heavily based in reflection.
Mm-hmm.
So just a warning to anybody out there. Basically, the goal is we don't want to do this anymore. Or this.
Okay.
We want to put something in here that tells Builder how to do that for us by sniffing all of the types in our assembly and finding types that have a special attribute on them. And I'm going to define this attribute up here. I'm going to create a inject attribute, and he's going to inherit from a string literal. Have you ever done attributes before, Zach?
No, I haven't. I'm familiar with them. I knew when you started to write that what that was, but I mean, I don't really work with them that much.
Okay, so we've defined our own attribute that we can apply to any class in our system to flag it. The attributes don't do anything in themselves. We just want to add this attribute to other classes so that we can pick up that they've been tagged, so to speak, later on. So I'm going to go into the Autofac controller factor because this is something that we have to inject. And I'm going to give him the inject. Then I'm going to go down to my in-memory entity storage, and I'm going to give him inject. Okay, so now they both have the inject attribute. Right now, nothing is being registered yet because, like I said, the actual inject attribute does nothing. It's just that we're going to, in our Global.asax, we're going to tell Autofac to basically register every single assembly or every single type in our current assembly that matches some sort of predicate. So we're going to say builder register assembly types, and then I'm going to actually alias this out into a variable, and then move them up because we need to use them right there. Type, what am I doing? It's not type, it's type.assembly. Okay, so register assembly types tells Autofac to start looking at every single type in our assembly. And then we have this where method that this isn't links where, but it does pretty much the exact same thing. We're actually not going to supply a lambda. We're going to supply a method, a reference to a method. We're going to call it find. We're going to call it is type injectable, and then we're going to define that method down here, just to make things more clean. Yeah, I mean
That's good.
Yeah, I see what you're saying, and hopefully this is what's going to actually help us find who has our attribute.
Yes, this method is going to, for a given type, it's going to return true
If it has
that
the
type
attribute.
has, right. And then at the end of this chain, we're going to say as implemented interfaces, and then we're going to say in. I was gonna mess up. I started out with Ninject, and Inject is in request scope. This one is instance per lifetime scope. So this says, look for all the types in our assembly, where that type matches our predicate, do the as implemented interfaces and stick them in the per lifetime or the request scope, like I like to call it. So now we're going to say if type get custom attributes type of inject attribute false. Don't know what I'm going to call this variable yet. Actually, hold on. This would probably be the best way to go about this particular issue. Just do that, and I like method chains starting like that. And then I don't think I have link. Do I have link? No, I don't have link. I'm going to just introduce a really cool little operator, a link operator, that it's called of type. Inject attribute. Actually, we can just return count greater than 0 or equals 1 because there should never be more than 1. That's probably just the fastest way to do it. I was thinking about another get custom attributes thing, because if you don't specify this, it'll just return every single custom attribute. Anyway, so this basically does everything for us right now. Do you kind of understand how that works, Zach?
Mm-hmm.
So now if we go ahead and build, probably get a lot of errors. Probably get a yellow screen. Huh, a yellow screen. The background's yellow. But I kind of meant the error. Yeah, you see it still works because our inject attribute is being properly registered with Autofac.
It's very nice.
Yeah, slick.
I wanted to introduce two more things really quickly. You notice how sometimes it's useful to inject things into the attributes or into the application scope. Sometimes it's useful to inject them into the request scope. So I'm going to add an enum called InjectScope, and he's going to have a request or application, and then our attribute is going to take a constructor argument, and it's going to default to request, and then we're just going to dump this in an auto property, the private setter. So now when we go here, we can say, instead of just inject, which now injects into the request scope, we can force it to inject in the application scope by specifying a parameter InjectScope.application. And again, this doesn't actually, we haven't done anything yet because we have to go into our code and pick up on that. And we do that because with this, we can do first or default. Actually, this would be less code. If I just did the other guy, the other overload that returns all custom attributes, and then just did the of type. Or no, I didn't do that. First place. There we go. So now we have an adder, and he's the proper type. So I can say return adder does not equal null. Adder.scope equals request scope, otherwise return false. We're going to rename this to isType in request scope. Then we're going to copy and paste this guy and do an isType in application scope. And the only difference is that instead of comparing the scope to request, we're going to compare it to application. And then we're going to copy and paste this line, and the only difference is that on this last thing is going to say instance per, or single instance. And then this is going to be isType in application scope. So now we have two predicates. One returns true if they have the inject attribute with the inject scope set to request, and the other one returns true if they have the inject attribute with the inject scope set to application. And we use that to two different calls to register assembly types. The only difference being, one at the end calls instance per lifetime scope, the other one at the end calls single instance, which registers this one as a singleton and this one as a per request.
Gotcha.
The last thing is the inject self. And remember how I said that, let's say we have a, let's say we have this. Here's an example of something that I might do. And person repository requires a entity service thing. What do we call that guy? Entity storage. And our person repository has or two. How about, this is going to look redundant for a second. all he's going to do is defer on to entities.store. But the important method is going to be the public IEnumerable. We're not going to be passing back an IQueryable because we don't want to. The person repository is going to be responsible for containing all the queries against what we would have a person, what we would need from a person database. So we return enumerable because we're kind of saying we don't want to do any additional querying after we return from this. And this is going to say get all people by name. And he's going to return entities.query person where enter p dot first name equals name there we go. Okay, so here is our person repository, and now our home controller no longer is going to depend on the identity storage, because identity storage is a pretty low-level concern. Our controllers are never going to actually ever be getting these guys back. They're just going to be getting back the repositories that work over the identity storage classes.
Mm-hmm.
So he's going to inject in a person repository. And we're going to say initialize field from parameter. So all that did was create a person repository and stuff it in there from the C2R argument. We're just going to replace entity. Actually, hold on, what am I doing? Change all local entities to person. There we go. And then instead of person.query, it's going to be person.get all people by name, and let's just do test, and then let's rename this from person because that's an awful name.
Yay.
There we go.
Cool.
So here's the problem. We'll get a big, fat, ugly new project dialog. A big, fat, ugly Autofac error in a second. And could you guess why, Zach or Jason?
No, not off the
Hang
top of my
on,
head.
hang on. Is your repository registered?
Oh, no, it's not. But well, thanks for reminding me. But it would still fail. There we go. But it'll still fail, and it's important if you look at one of these lines here.
Okay, go ahead and spill it.
As implemented interfaces, we're only registering the person repository as a class. He doesn't implement any interfaces. So this as implemented interfaces method isn't going to actually register him to anything, not even to himself. So if we refresh, we'll get none of the constructors found, cannot resolve parameter, person repository.
Okay.
To fix that, we need to introduce the concept of injecting to yourself, because I'll go over the architectural implications in a second. I'll just show you how to do it. We create another attribute called InjectSelf attribute. These are just names I came up with.
Very good.
Attribute usage. Specify it's only available on classes. He's not going to have any properties. He's just going to be something we can hook onto. And then we're going to do another one of these guys. The difference is going to be is type registered as self. We're going to delete the as implemented interfaces because this is going to take care of. This is going to be taken care of by if we also have the inject attribute on.
Mm-hmm.
And then we're going to do as self. And then we're just going to put in another method. Again, this could be a lambda. And all it's just going to do is say return type, get custom attributes, type of inject self attribute, false any. I don't know why I did count greater than 0 the last time. I just realized I did. It should be just .any. Anyway, if I build... Actually, this might work, but it's not preferable if it does work. Hope it doesn't work. Good. Okay, thanks. The reason it doesn't work is because although we have the inject self, we're not putting it in any scope yet because we don't have the actual inject attribute on it. And the reason I hoped that didn't work is because I don't want I want whoever implements this to be explicit about whatever they do. I've always just done the inject, or he doesn't even have the inject stuff. I just added the inject. Not paying attention again. Now if I go ahead and add the inject self again, that I didn't put in there before anyway, we get our stuff. So does that make sense?
Mm-hmm.
From an architectural standpoint, I mean, someone would look at this and say, well, you're coupling your controller to your implementation of your person repository. And I look at this, and it's already so abstract. What other stuff would a person repository do besides this? Besides depend on an entity store, some sort of storage, and then perform link queries on it. This is like as abstract as you get. It's not dealing with infrastructure code. It's not dealing with framework code. It's not dealing with platform code.
Mm-hmm.
It's only dealing with code that I've already abstracted. So in my mind, there's very, very little reason to go out there and create an interface called iPerson repository like, everyone will say that you have to or whatever. I generally, in instances like this, when my class doesn't depend on anything other than the abstractions I've built, I'll just inject self.
Gotcha.
Do you have any comments with that, Jason?
No, I don't. It makes complete sense.
So yeah.
I mean, what could you abstract away? I mean, you're
doing everything a repository needs to do.
your iEntity storage has already made sure of that, and you're holding the reference to entities, and
right.
I mean,
and if I need a configuration, I'll just grab an iConfig service, or if I need session, I'll just add an iSession service. And I just wouldn't. Yeah, but once you get to a certain point, like I said before, you just don't need to abstract anymore.
gotcha. Okay.
So are we doing NHibernate tonight too?
I would say tonight's probably pretty good, seeing how we're now at an hour and a half in. Unless you don't think it's going to be a very long thing. I mean, we've covered NHibernate already.
Nah.
That's
Yeah.
Go ahead. That's what I was thinking. So we can go ahead and wrap it here. This gives people quite a bit to chew on, actually. And then we'll hit it again and cover NHibernate and go from there. Does that sound good?
Yeah, sounds good.
All right, fantastic. Well, thank you very much, Nelson, as always, and you too, Zach.
Thank you.
And a giant thank you to our member sponsors out there in 3D Buzz Land. And that will conclude episode 8 of Application Development with ASP.NET. Thanks, everyone.